Welcome to another tutorial video with Ms. Taylor. In this particular video, we're going to be looking at how to balance redox reactions that occur in basic solution. If you are not familiar with balancing redox equations in acidic solution, I suggest that you first go watch the acidic solutions video and then come back to this one. However, they are similar. And so I'm going to start by assigning oxidation numbers just in case we have to specify in a problem what is the oxidation half and what's the reduction half. So we have a monoatomic ion here, -1. We've got oxygen, that will be -2. We'll have to calculate chlorine for this one. So it's a polyatomic ion. Its overall charge is -1. So in order to keep that, chlorine actually has to be a +1. Interesting and weird. Iodine is going to be 0 because it's in its elemental state, and then the chloride ion is a monatomic ion. It's -1. So let's examine what happened. We had iodine go from -1 to 0. And we had chlorine go from +1 to -1. So to go from -1 to 0, you have to lose an electron. So that is the oxidation half. And to go from +1 to -1, you had to gain 2 electrons. So that is the reduction half. And in case you're wondering where the oxygen went, it was actually supposed to be plus water. And so we have hydrogen's a +1 and oxygen's a -2. And that would have come up anyway in the course of balancing this, but I'm just going to balance it as if that had not been written, but before your brain exploded and you were like, wait, where's the oxygen? That's where it ends up being. So I'm going to erase that. And let's move on to balancing our halves. So we'll do the oxidation half first, just because. Alright, we have the iodide ion. We'll leave some space because I'm going to have to add some things. Going to elemental iodine. Okay, so the first step in balancing half reactions is to balance the atoms. We have 2 iodines on the product side, but only 1 on the reactant side, so we balance that by 2. And in this particular half, we do not have any oxygens or hydrogens to deal with. We will deal with that in the other half. So we need to balance the charges. And our reactant side has 2 iodide ions, making it a -2. Product side is 0. The only thing we can do is add electrons, so I'm going to add 2 electrons to the product side, which makes sense because this is an oxidation half, and if you're losing electrons, then electrons should be a product. Let's move on to the reduction half. We've got the hypochlorite ion. Again, I'm going to leave some space. Going to chloride ion. Okay? So nothing to balance with the chlorine atoms because they are the same. However, we now have to start taking care of the oxygen. Just scroll that down just a tad. Alright, since there is 1 oxygen on the reactant side, we're going to have to add a water molecule to the product side to make up for that, like I was showing you earlier. But now in adding water, we've added hydrogen, so to balance that, we're going to add hydrogen ions back to the reactant side. And before we're finished, we have to check the charges. So we've got a -1 and +2, so we've got a net +1. And over here we have a -1. Now we need our 2 halves to match as far as charge goes, so I'm going to add 2 electrons here, because that will end up giving me -1 and -1. And, haha, actually our electrons this time are going to cancel out on their own. If your electrons do not cancel out, you have to multiply both halves by a factor so that when you sum the half reactions, they will cancel out. But I apparently picked an easy one for this particular tutorial. Alright, so now I'm going to bring down my reactants and products. So I have 2 iodide ions, a hypochlorite, 2 hydrogen ions. Onto the products, we've got some elemental iodine, a chloride, and a water. Now, if this was done in acidic solution, we would be done, but we're not. Since we are balancing this in basic solution, we have to add another step. What do we have to do, you ask? Well, you have to remember in basic solution, you have extra hydroxide ions floating around. So those 2 little hydrogen ions on the reactant side are not just going to hang out. Okay? They're going to react with hydroxide. So what you have to do for a problem in basic solution is you look at the number of hydrogen ions that you have and you add that many hydroxide ions to both sides. Not quite finished there though, because when you add hydrogen and hydroxide together, you make water. But wait, still not done. We have water on both sides of the equation. We have 2 on the reactant side and only 1 on the product side. So I'm going to make the product side water go away and reduce the coefficient of that water to just 1. And now I can rewrite the balanced equation. So we end up with 2 aqueous iodide ions, 1 hypochlorite ion in solution, plus a water molecule. And we are yielded some elemental iodine, chloride ion in solution, and 2 aqueous hydroxide ions. And there is your balanced equation. Happy balancing. Thanks for watching.